Okay, the tool I'd like to introduce today is the Remax spring pressure testing tool. This tool is used to establish the installed spring tension of the spring that holds the valve in position when it's reassembled in the cylinder head. The other relative measurements that we need to take a look at is the spring open pressure and the spring close pressure. So it's how the spring is sitting assembled in the cylinder head. So the tool here, it has a scale on the side that gives us a variation of readings. The readings go in increments of typically 20 to 40 thousandths of an inch at a time. Now, if your specification falls between those ranges, then it's going to be hard to establish the exact measurement. So what we're going to do is we're going to use our vernier caliper and then adjust the tool to meet the table height to fall within exact specifications. Now, the manufacturer of this particular style of spring happens to use a double wound or counter wound spring assembly. The one main spring and the wire diameter of the spring controls the opening and closing and the maintained spring tension on the valve assembly while it's put together in the cylinder head. The other spring that's on the inside is a counter wound thin type spring, and what that does is it sets up the equal and or opposite reaction of the oscillation of the primary spring that actually moves and creates an imbalance in the valve train as it's opening and closing. The counterwound spring sets up the equal and opposite reaction to control that so that we minimize dynamic valve flutter. That's an oscillation that happens in the valve train that is a destructive force on the seat and on the valve face itself. So the manufacturer, and again looking at specifications for this particular assembly, is we're looking for free length, installed length, open pressure, and closed test pressure. Now the manufacturer gives us particular dimensions in inch value and gives us a pressure value in pounds per square inch. So what we need to look at is, one, the dimensional amount, and two, the amount of pressure that's related directly to the test procedure for the valve spring. So the manufacturer of this particular valve says that the free length of the valve, which we can very simply measure with a vernier caliper, is 2 inches, 225 thousandths of an inch. Now, if I take that dimension, I can check each and every one, and this one seems to be a little looser or smaller. Right about on the money, and the last one seems to be slightly tighter. Okay, so that's one way of doing it, the free height or free length of the spring. Now, if we had all of the springs on the bench, we could take a straight edge and lay it directly across the top of them to check to see if they're all at the same height. Any one that's lower or higher would be in question for installed spring height. We don't want it lower, because if it's lower, then we have less spring installed tension holding the valve on its seat and controlling it through its movement open and close as the camshaft allows the rocker arm to open and close that valve spring. So the next thing we're going to do is to check it on the Remax spring tester. So all I'm going to do is, instead of trying to read the very fine small gauge, which I think does not even fall into my specification, the closest one I have is 187 or 2.187 to 2.250, and our spring free length is 2.225 inches. So by guessing, we're not falling within manufacturer spec. We already have the measurement established. So what we're going to do now is we're just going to put it on the table, and we're going to bring the tool anvil down. And if you watch here, you'll see it just start to move as I make contact. Okay? And once I've made that contact, I can now set the lock, checking that I'm not deflecting the pressure gauge. And now it is set at 2 inches, 225 thou, and I can check all 4 springs in question very quickly and rapidly to determine, do I have good springs to actually start testing. The scale just starts to read. Just starts to read. Just starts to read. And reading a little more than it should, which tells me that this spring, and like I originally measured with the vernier, that this spring was one in question being slightly larger or tighter than the rest, which it is also with the vernier caliper. So this one here is the one in question that may have a dimensional problem. The rest are either all below spec or they're right on. Okay, so the next test we're going to do, one is we've established the free height. So that's, does the spring have a free height available to do the work once it's put into position in respect to where it sits in the cylinder head? So the next one is our installed height, which is 1 inch, 860 thou. So I'm going to look at the scale on here just to see if we have it. 1 inch. 750 to 875. So no, it doesn't fall within specification on that scale. So now I'm going to set it just like I did with my free height at 1 inch, 860 thou. So 1 inch, 800, 25, 50, and 10 gives us the 860. So 860 thou. I'm going to go back in here and adjust the table again now to come down until it just starts to deflect the gauge at the bottom, which is just touching, and you can see the needle moving. We'll back it up just a little bit. And now I'm going to set the lock. Now this table is set for all the installed spring height on this particular valve. So this valve spring. So now if I take it in here and I bring it down till it stops at the top, and I read the pressure, it's showing me on the scale here that the pressure is just under 100 psi. The manufacturer's spec for installed height is 100 psi, and I'm coming in just at about 95. The next one, this one's coming in at 90. The next one is coming in at 90 psi. And the very last one out of the 4 that we're testing today comes in at about 75. Okay, so manufacturer spec says at 1.860 thou in this area here, that we should have a minimum of 100 psi spring installed pressure. That's the pressure installed height, is where we're going to have the valve spring sitting compressed with the keepers and the retainer and the valve assembled in the head. That's the pressure that we need, the 100 psi, to maintain consistent contact between the valve face and the valve seat, and giving us the correct position of the valve when it's sitting in the cylinder head. So at this particular point, we have one in question that tends to be out of range for free length, and we have 4 of them, 3 out of 4, that fall below manufacturer specs of 100 psi installed. So now the open spring pressure, so that's now when the camshaft cycles around, starts to push on the rocker arms, opening the valves. So what we have to do now is take a look at the open pressure, which is 1.430 inches. And I'm just going to dial in my vernier caliper at 1.430 thou. 25, 30 thou. Okay, now I'm going to take that measurement I'm just going to have a look to see if we're close at 1.430 on the scale on the tool. 1.375 to 1.437. So again, it doesn't fall within the spec on the scale. So I'm going to use my established measurement, put it on the table again, bring it down to the spring open pressure just till it starts to touch, and deflect the scale. Now I can lock it, just recheck it. Now this is quite a bit smaller difference or distance that we're looking at now compared to the free length and the installed height. So if I open the tool back up, now we'll take the one that's in question that has failed both tests to begin with, and I'm going to bring it down. Manufacturer spec on this is 225 pounds of pressure at 1.430 inches. So I'll bring this one down. And we are sitting at 230 psi. Manufacturer spec on this one is 225. So the top end of the spring pressure is greater than the bottom end of the spring pressure. The bottom end is a very crucial one because that's what's actually holding the valve on the valve seat when the valve is closed in the head. The top end pressure, having a little bit higher than manufacturer spec, is going to help control valve float. And it's also going to create a bit of a slight problem where we have too much installed open pressure, and that can cause hammering on the seat when it slams shut, depending on the camshaft profile. So if we check the next couple in question here. Let me get back on this side. And this one comes in at about 210. So again, this one fails compared to the other. So the one that was in question for free length and installed height failed, but passes the open pressure. The next one fails. This one fails also at 210 at prescribed height. And then this one probably fails also at 210 also. So these springs here, there would be no question in my mind because of the variation of the installed free height and open test pressures that we're checking, that these springs fail. Okay? So to put them back in the engine is not a very good insurance policy for the customer or even for your own equipment. The problem happens is when we overspeed the engine and we get valve float. The open spring pressure is below spec, except for the one spring, which is not going to control the valve being able to follow the camshaft profile down till it's shut, and then the installed spring height pressure to maintain it on its seat to provide the sealing. So in Adjust, this is how we go about checking our free length, installed height, and open spring pressure for engine valve springs. 100